Hi! The crew of Axiom 4 mission recently returned to Earth after a successful endeavor on board the International Space Station or ISS. For three countries, India, Poland, and Hungary, this was the first time stepping foot on the International Space Station and only the second time that one of their own went into space after more than 4 decades in each case. In this episode of the Astronomy class, we'll decode the global significance of this mission of Axiom Space and what it means for the future of space exploration for the world and particularly for India. So without any further ado, let's begin. This is not just the beginning of my journey to the International Space Station, but the beginning of India's space program, said Group Captain Shubhanshu Shukla 10 minutes after the Dragon capsule successfully lifted off with SpaceX's Falcon 9 rocket on June 25. Shukla was the proud pilot of the Axiom Space's fourth mission, which was launched from NASA's Kennedy Space Center in Florida in the United States. This mission is very special because it marks a historic return to space for its three partner nations, India, Poland, and Hungary, in over 40 years. This was also the first time that all three countries executed a mission on board the ISS. From an Indian perspective, this is a milestone in the history of the Indian space program, making Shubhanshu Shukla the first Indian to set foot on the ISS and only the second one in space following the footsteps of Wing Commander Rakesh Sharma. Sharma flew aboard the Russian Soyuz T-11 back in April 1984, and since then India has been waiting to cross the milestone achieved by Shubhanshu Shukla. The Axiom 4 mission had a crew of 4 members, including the legendary mission commander Peggy Whitson, who is a former NASA astronaut and the director of human spaceflight at Axiom Space. She has spent the longest accumulated time in space than any other American ever. Mission pilot Shubhanshu Shukla of the Indian Space Research Organization, Szlaos Uznansky from Poland, represented the European space agencies along with Tibor Kapu from the Hungarian Space Office. Shubhanshu Shukla is the youngest of 3 siblings born in a middle-class family of Lucknow. His father was a government employee and his mother is a homemaker. Shubhanshu is a computer science graduate and trained as an Indian Air Force test pilot before he was selected as one of the first 4 Gaganyatris for the Indian human spaceflight program. Shubhanshu completed his military training from the National Defense Academy in the year 2005 and was commissioned as an IAF flying officer in the following year. Even though this was his first trip to space, Group Captain Shubhanshu Shukla is a seasoned pilot with over 2,000 hours of experience in flying a variety of fighter spacecrafts such as Sukhoi 30, MiG-21, MiG-29, Jaguar, Hawk, etc. These fighter aircrafts do not cross the Earth's atmosphere, but they are capable of attaining very high speeds reaching thousands of kilometers per hour, making Shukla an ideal candidate for the Axiom 4 mission. Shubhanshu was shortlisted by the Institute of Aerospace Medicine, an organization under the IAF, for the Indian Human Spaceflight Program, Gaganyaan, in the year 2019. The very next year, his team of first 4 Gaganyatris was sent to Russia's Yuri Gagarin Cosmonaut Training Center for a year-long training. After their return to India, the Gaganyatris trained at the astronaut training facility in Bengaluru. During this time, all 4 of them, including Shubhanshu, enrolled for a master's degree in aerospace engineering from the Indian Institute of Sciences. While his supervisor at IISc is very proud of him, he awaits Shubhanshu's arrival back on the campus so that he can complete his master's thesis on the subject of space habitation, of which he now has a good experience as well. But the Axiom 4 mission is not limited and important for the 4 countries involved. It serves a true example of global cooperation. The crew carried out 60 science experiments and outreach activities representing 31 different countries, including the United States, India, Poland, Hungary, Saudi Arabia, Brazil, Nigeria, United Arab Emirates, and nations across Europe. This was the most research and science-related activities conducted on an Axiom Space mission aboard the ISS to date, making this mission globally significant for advancing microgravity research in low Earth orbit, also known as LEO, which is 400 kilometers above the surface of Earth. During his 18-day stay on the ISS, Captain Shukla led 7 microgravity experiments spanning agriculture, biology, and human adaptation in space. All these experiments were exclusively designed by ISRO in collaboration with various research institutions from across India. These experiments will help design efficient modules for Gaganyaan, improve our understanding of the limitations of the human body in almost zero gravity, and consequently test ways to overcome those restrictions in the future space missions. One of these experiments is on the theme of myogenesis. Astronauts on long space flights lose muscle mass very quickly. The lack of gravity means that the muscles no longer experience the downward pull, and the flow of fluids, including blood, are affected as well. This leads to symptoms like puffy face, chicken legs, and even increase in height for the astronauts. Recall how skinny astronauts Sunita Williams and Butch Wilmore looked after the return to Earth after a prolonged mission aboard the ISS earlier this year. Lack of gravitational pull in space decreases the ability of muscle cells to regenerate. Researchers believe this is because the microgravity environment interferes with the metabolism in mitochondria, which are tiny structures responsible for producing energy in cells. ISRO's myogenesis investigation used muscle stem cell cultures to examine the muscle repair process and test chemicals known to support functioning of mitochondria. This research will not just further our understanding of human health in space, but will also benefit studies exploring age-related muscle loss for common people on ground. Ever wondered what astronomers eat in space? Well, a lot of research is underway to test which food items can be consumed in space by the astronauts in order to maintain their health and provide them with ample nutrition. For instance, bread does not work because it leaves around a lot of crumbs, but tortillas work well as a substitute for making all sorts of delicacies like wraps, pizzas, and even burgers. Since there is only a chiller for drinks and condiments and no refrigerator or freezer on the space station, all food items should survive at normal temperature for several days. This implies that there are not many options to eat fresh produce like fruits and vegetables, impacting astronauts' digestive health and making them crave for such foods during extended stay in space. Captain Shukla carried with him moong sprouts, radish, and fenugreek seeds, along with seeds of some native Indian food crops to study their growth in microgravity environment. The samples grown in space brought back by him will be cultivated repeatedly for several generations to test any changes in the nutritional value and growth rate in subsequent crops grown from seeds which were exposed to microgravity on the ISS. These experiments will fuel a series of studies testing growth of food crops to provide sustained nutrition to astronauts on the space station and later on the surface of Moon and Mars once we set up base on those faraway lands. Designed by the International Center for Genetic Engineering and Biotechnology, another experiment tested 2 strains of cyanobacteria to investigate their growth rates, cellular responses, and biochemical activity in microgravity. Cyanobacteria are aquatic bacteria which can photosynthesize to produce oxygen, making them useful in the development of life support systems for future space missions. Cyanobacteria can also recycle the waste produced on the space station and hence play a critical role for long-term sustained living in space. Captain Shukla will also test 3 strains of microalgae for rate of growth, metabolism, and genetic activity in comparison to their counterparts on the ground. These edible microalgae are highly nutritious and can become an important part of astronauts' diet in long-duration space missions in the future. In addition, research is in progress to study their use as a fuel and even in life support systems on board the next generation of space stations. Research shows that human interface interaction changes in space. Shubhanshu carried out a very interesting set of experiments which analyzed parameters such as rapid eye movement, gaze fixation, and pointing tasks among astronauts to study the impact of their interactions with the electronic displays around the ISS. The results of this experiment will help in lowering stress levels among astronauts by improving the design of electronic displays in future spacecrafts, space habitats, and even for aviation on Earth. Tardigrades are known to be one of the most resilient forms of life on Earth. They are almost impossible to kill. Tardigrades are tiny creatures about half a millimeter in size when fully grown. They are found to have survived the chill in the Arctic, heat around volcanoes, and the brutalities of rainforests with the same zeal. Captain Shukla carried with him hibernating tardigrades requiring no food and zero metabolism. He revived them in space using water. This experiment studied the revival, survival, and reproduction pattern among tardigrades which were sent into the International Space Station. Here is an interesting fact about tardigrades. In 2019, an Israeli spacecraft crashed on the surface of the moon, spilling tardigrades on its surface. While it was reported that they must have died due to the high velocity impact, some scientists still joke that they might be thriving as the only living creatures on the moon, waiting to be rediscovered by us. Besides these scientific research experiments, Captain Shukla interacted with school students via live video and ham radio sessions and answered many of their questions about life in space, the International Space Station, and challenges faced in microgravity. He also conducted a set of experiments as part of the science, technology, engineering, and mathematics outreach activities and clicked picture of Earth as requested by the students. Axiom 4 was a critical and strategic stepping stone for ISRO as it prepares to send a crew of Gaganyatris to the LEO for several days in 2027. Even though the Indian astronauts are undergoing extensive training on the ground, nothing compares to the practical in-house knowledge that Shukla gained as a pilot of this space flight and his stay on the International Space Station. This event was also different from the spacefaring endeavor of Wing Commander Rakesh Sharma 4 decades ago for two major reasons. Firstly, the wide-scale presence of social media ensured that every child and adult around the globe not just heard but witnessed the launch and landing of this historical mission. Secondly, in 1984, India neither had the resources nor the confidence to initiate a long-term space program. But in the last few decades, ISRO has not just established itself as a global leader in launching cost-effective satellites, but also underscored its intentions to lead a sustainable space program with the iconic Chandrayaan missions to the moon and also its frugal Mars orbiter mission. India is now ready for its leap into the future of space exploration. As Gaganyaan is being prepared to take flight in less than 2 years' time from now, the tedious and rigorous training of our Gaganyatris will culminate as the first manned spaceflight into LEO. Meanwhile, ISRO is bringing its vision of an indigenous space station to form. The Bharatiya Antariksh Station, or BAS, is expected to become fully functional with all 5 modules in LEO in 2035. The Indian space station will be assembled in space with the first module scheduled to fly no later than 2028. Human spaceflight requires a very high level of precision and safety protocols which must be followed rigorously to honor the limitations of the human body. No amount of psychological conditioning and physical training done with the aid of simulators can compete with the experience that Captain Shukla gained during his 18 days long endeavor on the ISS. He not just conducted science experiments but collaborated with fellow crew members from different countries, gaining the true flavor of complex team dynamics and global partnerships. On this mission, Shubhanshu dealt with complex spacecraft systems as the mission pilot for Axiom 4, which provided him with invaluable experience and expertise for Gaganyaan. But even while preparing for the mission, Shukla underwent a year-long quarantine, received extensive medical and physiological conditioning, and trained for all phases of the spaceflight and life of limitations and confinement on the ISS along with his crew members. And now that he has experienced the life on the ISS, his learnings will directly feed into the preparation and modules for the Gaganyaan, helping ISRO understand and apply global standards of protocol to our upcoming space mission. Going beyond the materialistic and logical learnings, there are deeper lessons to be learned from Axiom 4 mission as well. As Shubhanshu mentioned in his conversation with the Prime Minister, even though India looks grand from space, all boundaries between various countries become invisible. From space, Earth appears united, and the realization of oneness and unity among all of humanity becomes profound, echoing the ancient Indian philosophy of Vasudhaiva Kutumbakam. All Earth is one family. While he did introduce his fellow astronauts to special Indian delicacies such as amras and gajar ka halwa and taught them the benefits of yoga, Shubhanshu himself has gained invaluable insights into how a culturally diverse team functions in the constrained environment of the ISS, which will come in handy in preparations for the Gaganyaan. Right now, humanity stands at the turning point in the era of space exploration. The first and third Axiom Space missions worked in close collaboration with Amazon, taking an Amazon Web Service system to space. Amongst others, research is underway on the ISS to develop a variety of advanced materials for various industrial applications. For instance, optical fibers produced in almost zero gravity have less imperfections, leading to low signal distortions and higher and more reliable data transmission rates. Several drugs developed and tested in the microgravity environment of the ISS by United States Food and Drug Administration have recently been approved for clinical trials on ground. So while it is already possible to have orbital data centers and conduct research in space, setting base on Mars and settlements on Moon will require mass-scale production of various products in space itself. If things do continue to move at the current pace, I won't be surprised if we are surrounded by products manufactured in space in a decade's time. The International Space Station is expected to retire by the end of 2030, 3 decades after it became fully functional. Meanwhile, Axiom Space is partnering with NASA to launch the first module of the Axiom Space Station, which will be the world's first commercial space station and a successor to the International Space Station. All modules of the Axiom Space Station will fly as independent spacecrafts starting 2027. Each of these modules will be fully equipped with all systems, including propulsion required to maneuver in the orbit. This unique capability will allow various nations and industries to collaborate with each other or work independently, carry out an independent research program, or build systems for mass production in LEO just by sending a dedicated module. The Axiom Space Station will therefore become a space habitat which could be expanded indefinitely based on customer demand and requirement. But until then, in India, the nation continues to take inspiration from our spacefarer hero, Group Captain Shubhanshu Shukla, and reminiscing the glorious visuals of a bright-eyed Captain Shukla walking out happy and healthy out of the Dragon capsule with his usual calm demeanor and cheerful smile. I hope you enjoyed this little overview of the Axiom 4 mission, Captain Shukla, and my views on the future of space exploration from an Indian perspective. Do let me know if you ever thought about going into space. Let's catch up in the comments section below. And if you are enjoying our content, please do share it with other astronomy enthusiasts. And don't forget to like, share, and subscribe our channel. I'll see you next week. Until then, take care.